migration north and south, and distinct assemblages of organisms along those coastlines. So there's many, many more marine provinces at the present time than there were 20, 30, 40 million years ago. So that's one particular project I'm interested in, and this really just summarizes what's happened since the Eocene. During the Eocene, because you had an open Panamanian isthmus, you also had an open gateway between Europe and the Indian Ocean through the Mediterranean that was open to circulation. The organisms right through what are presently tropical areas had a great deal in common. So for example, the mollusks that I studied that lived in Indonesia, very, very similar to the ones that lived in Iran, well, are found in rocks in Iran and in France. There's very, very little that's different about them in terms of their composition. By the time we get to the Pleistocene, that's certainly not the case. There's very little in common between Indonesia and the Mediterranean or Europe in terms of the molluscan faunas. Okay, I'll just skip on from that. So I mentioned before that this thermal gradient, this change from warm waters in the tropics to cooler waters, represented by the blue and green colors in this map, that affects the organisms, and it not only affects the distribution, but it also affects a number of different species that we see. This is known as a latitudinal diversity gradient, and this is some work by a colleague of ours, Dave Jablonski and Karstof Roy, and what they've shown very eloquently is at the present time in both the Atlantic and the Pacific, tropical areas of North America and Central America, so for example around here, have many, many more species, perhaps as many as 10 times as many species as what we refer to as temperate areas, for example, the Atlantic coast. So this is known as the latitudinal diversity gradient, and it's something else that I've been studying in great detail, and I won't show you the data on it, but essentially what we see is if you roll the tape back to the Eocene or the Paleocene, you had a much flatter curve. You didn't have this dramatic drop. Fairly flat curve of diversity. The Arctic and the Antarctic paleoenvironments were much more hospitable to organisms. And in fact, in New Zealand at the present time, you don't see coconuts or warm water organisms, tropical organisms like coconuts living today, but you did during the Miocene and the Eocene, much warmer times. Conversely, today we have a lot of penguins living around our coast. So it's just an indicator that temperatures have changed quite significantly. Okay, now I told you I did a lot of daydreaming and imagination. In order to study things like provinciality and biodiversity, I spent a lot of time reading books, going through the primary literature, and amassing a large database of fossil occurrences around the world of different ages. And I wanted to tell you about one particular piece of literature. Whenever I read these papers, these books, I think about, gee, what would it have been like to be collecting fossils, from this particular area at this particular time. And some of the material I've been working on comes from places that you can't get to at the present day. If I could visit Somalia and Pakistan, Iran, Myanmar, those are probably the 4 or 5 top places I'd want to go that have wonderful Cenozoic fossil records that just aren't very well studied. They're there, they were described early on last century when things were a little bit politically more stable, but not since. And I think it would be wonderful to go back there. But I thought I'd just show you one example. The Dominican Republic, a country that's on the island of Hispaniola, it neighbors Haiti in the Caribbean, has a brilliant fossil record, Cenozoic fossil record, and this was studied back in 1917 by a woman called Charlotte Loring. And there's a picture of her on horseback as she rode around the country collecting fossils. Now, I just want to show you a quick map. I think this is quite amazing, just to take a quick detour for a second. Here's a map that she produced when she was doing her fieldwork. And on this map are annotated some quite wonderful things. Okay. Rioting tribal bands threaten the lives of the explorers. This fieldwork that she was doing was taking place during, I guess, a bit of civil war during 1914 and 1916. Okay, there's another one on the right-hand side here. Large rebel band in trenches, lots of looting and burning. All Americans flee. So it amazes me at this time people collecting in these areas, and I often think about this. F5, that's right. I'll remember. Oh shoot, that could take a while to live. I often think about this as I'm reading this literature. Can I go F5 now? No. Must be a new version of PowerPoint. Okay. So the last thing I was just going to mention is the other project I've got going on at Yale, and the reason I'm really there in the first place is to work with a professor, Derek Briggs, and he's an expert in exceptional preservation and taphonomy of soft-bodied faunas. So one of the things I'm interested in is how different preservation of organisms through time might bias our perception of biodiversity. And if you think about the variety of organisms we see in marine environments, let's see if I haven't got a slide to show that, but the soft-bodied things I showed at the very start, the sea anemones, for example, the starfish is not a particularly well skeletonized organism. These things are going to be preserved differently as fossils relative to brachiopods. So I'm interested in how this might affect our perceptions of biodiversity, and that's what one of my projects at Yale focuses on. And just thought I'd show you a couple of slabs of Paleozoic assemblages, and you'll see that they're hard rocks. You can't necessarily get the fossils out of them. And even around the Cope Formation, when you pick up your nice catastrophias or your loose Triarthris, you can't necessarily see all the delicate internal features, the appendages gone. You can't crack open your catastrophia and see the lophophore on the inside. These are things we can do with much better preserved fossil records, say in the Cenozoic, or even in the present day, recent material. So I'm interested in how this process of lithification, that is turning sediment into rock, affects the fossil record. Now this is just a graph of published fossil occurrences, and it's showing the proportion that is preserved as rock or as loosely preserved specimens you could sieve, for example. And those are the ones that are shown in red. And you can see from the Jurassic through to the the Cenozoic, the last 60 million years here, there's a rapid increase in this very well-preserved fossil material. Now, if you look at the number of organisms, the number of different species in each collection from a particular locality, a particular horizon, along the same time series from the Jurassic through to the Cenozoic, you see that the number of, well, in this case, genera almost doubles. And people often think of marine communities as becoming much more diverse through the Mesozoic and into the Cenozoic. That probably is true that they did become more diverse, but by how much is something that's being argued about at the moment. And I would contend that